numerical computing video. I'm Fashi yar from B3. Today we're gonna learn another example of bisection method. So without wasting any time, let's go further. So let's get start the explanation of the example. The example we have is x square plus 2x minus 8, and the intervals we have 1 and 4. The root is lying between these 2 points 1 and 4. So first we have to put 1 in this equation instead of x. So we get the function of a is minus 5, and at point b it's a point b. At point b we have 4, so put the 4 in this equation instead of x. We get 16. So we get function of a, function of b, and similarly as we discussed in our previous video how we get c by taking the average of these two intervals a and b. A plus b upon 2, 1 plus 4 upon 2 is equals to 2.5. we get the c point, and now put the 2.5 in this function and we get function of c. Now put all of these things in the table. So x is equals to 1, a is equals to 1, and function of a is minus 5. Okay, so put x is equals to 4 and we get the function of b is 16, c is 2.5, and the function of c is 3.25. now the function of b and function of c has a similar sign, so they replace function of c replace the function of b, so it will be 3.25, and 5 remains minus 5 remains as it is, 1 remains as it is, 2.5 replace the 4. Okay, so now take the average of these two values 1 and 2.5. 1 plus 2.5.2 is equals to 1.75 is the c, and function of a is minus 5, function of b is 3.25 as we replace it, and the function of c is minus 1.437. so function of a and function of c have the similar sign, so function of c this time replace the function of a, and c replace a. b remains similar. Now we get the average of these two values, and it's 2.125, and put this value on the function of on the equation, so we get the 0.765. so we continue the iteration until we get the root. So without wasting any time, let's jump into the code. So in our previous video we code the bisection method on Python language, so today we code this on Java language. So let's get started. First we have to make a class named bisection method, and let's take two functions in it. First function is the function that take the equation, return the equation that we find, that for the equation we have to find the root. And second is the main function, that bisection method implementation. Okay, that takes three parameters. First is a, b, that are two intervals, and the tolerance level. Then we initialize the variable c in this function, and the iteration, that means the iteration start from 1. Okay, so then initialize a while loop, that's take an argument b minus a is greater than equals to tolerance, and then find them, and that put the formula of midpoint, c is equals to a plus b upon 2, that's the value of c. Okay, first c is equals to 0, and then a plus b, a is equals to 1, 4, that means c becomes 2.5. okay, then initialize the if condition. If equation c double is equals to 0, equation c is equals to 0, that means we find the root and break and out from the root and out from the if condition. Okay, then if not, print the intermediate result, and then again we initialize the if condition. If equation c into equation a is less than 0, so b is equals to c, else a is equals to c. In this equation we are swapping the values, and then iterate the iteration. That means the first time it's 1, second time it's 1 plus 1 2, third time it's 1 plus 2 plus 1 is 3. Every time it's iterates 1 itself, then returns c is the answer, root. Then we come into the main method. That's then we there is initialize a parameter a is equals to 1 and b is equals to 4 as we discussed in our example, and the also define the tolerance level, that is 0.0001. That means where we get the function of a, b or c 0.0001, it means we get the root. Okay, so then we also initialize call the function as name root bisection method a, b and tolerance. A, b and tolerance we also define above. So now call the function in this method, this, then we print the result. Okay, so let's check how it's work. So we get the we get the root at the 15th iteration at the point 2.000305. Okay, if we put 2.000305 in function, we get the tolerance level 0.001. Hope you guys like the video. So see you in the next video. Allah Hafiz.